In the caffeine experiment a few days ago, we talked about different ways that we could improve it, make it better, have comparisons. We talked about what happens with people who are more sensitive to caffeine and how random assignment helps. Well, there's something else that can specifically help with the experiments if you know that two groups are going to have a different reaction. So let's say that in the caffeine experiment, females have a different reaction to caffeine than males do. Okay, that makes gender a lurking variable because then we would look at our results, and it might be the case that if we get results, we might not know which caused them, the caffeine or the gender. Okay, so what are some ways that I could deal with that? Well, I might just eliminate a gender and only focus on males or only focus on females. However, that's bad because it's going to give me a smaller scope of inference. I won't be able to apply my results to males if I don't include males in my study. So what we can do is we can do something called blocking to make sure that we balance the gender in the treatment groups. Okay, and so what blocking is that you split, before you randomly assign your treatments, you split purposefully into groups. So if I had 30 students in my class, before I split them into groups, I would put the males in one pile, the females in another. Then using the hat method where I put all their names on a piece of paper, put them in a hat, mix them all up, etc., then I would randomly assign to either caffeine or no caffeine. And then I would compare the results of the treatments for the males. Okay, likewise, I would do the same thing for the females. I would randomly assign them to either caffeine or no caffeine, and I would compare the results of the females. Okay, this is called blocking, and it allows me to, knowing that there's a difference between males and females, I can compare the results in the male group and compare just the results in the female group and see how it affects males and how it affects females. Okay, so a block is a group of similar experimental units. Okay, these experimental units could affect your explanatory variable. Okay, so how do you choose which variables to block for? It needs to have a strong association with the response variable. So in our other case, we knew that females have different reaction to caffeine, so there needs to be some kind of a strong association. Okay, something that is very important to remember is that blocking is not done randomly. Blocks are not formed at random. They are picked for a purpose. And you need to be able to explain the purpose and why you picked the blocks you did. Okay? The putting them into blocks are not random. Okay? It is the random assignment of the treatments within each block that is random. Okay? This part right here is the blocking. I specifically split them up into males and females, and then within each block randomly assign the treatments. So blocks are not random. Okay, so in this experiment, what else could we block for? We could block for maybe age, or we could block for weight. Okay, we could block for other things that might affect whether or not the caffeine affects the person or not. Okay, so we're looking for things. We are looking for things that would affect the impact of caffeine on the person. So age, weight, body size, like body fat, maybe things of that nature. Okay, so let's look at this experiment here. Anne is an avid baker. So let's look at this example here. Anne is an avid baker who would like to compare two different chocolate chip cookies, A and B. So she recruits 10 volunteer taste testers, and they each are asked to rate the cookies on a scale from 1 to 5. So she's going to make 10 of each type. Each cookie tray will only hold 10 cookies, so she has to use 2 trays and bake them at the same time in the same oven, with 1 sheet on the lower rack and 1 sheet on the upper rack. Okay, explain why a randomized block design might be preferable to a completely randomized design. Okay, I have a couple of things that I cannot help, but that could become confounding. For example, if I like recipe A better, how do I know that it's not because the cookie I had was on the lower rack or on the upper rack? Okay, the position is a variable that I might block for. So if I'm going to outline this, what I would do is I have my 20 cookies. Okay, my treatments are the recipes. Block according to the rack that they were on or the position. So I would have 10 cookies on the lower rack and 10 cookies on the upper rack. Okay, so in that lower and upper rack, I would do some random assignment in each one. And I would randomly put 5 cookies of type A and 5 cookies of type B. And down here I would randomly put 5 cookies from type A, 5 cookies from type B. Then I would compare these results, and I would compare these results. So I don't compare them all. I just compare the lower rack to the ones on the lower rack and the upper rack to the ones on the upper rack. So that enables me to say, okay, for the lower rack, which cookie tasted better? And for the upper rack, which cookie tasted better? And it may be that they're the same cookie on both racks. It also may be that they're different cookies on different racks, which means that the position of the cookie in the oven also had something to do with it. So we block so that we can help account for a variable that we cannot control. So let's talk about this idea of matched pairs. Matched pairs is simply a block of size 2. When we did the experiment of the Stroop effect, many of you pointed out that it would be a better experiment if the same person did both the words and the squares. That's also a matched pair. Your block of size 2 can be the same person who does both. So I may do the blocks and then look at the words. Okay, so that is a block of size 2 if I do both treatments myself. So it's either 2 people doing the same treatment, or 2 experimental units having the treatments, or I might have the same person do both. Okay, even if I have the same person do both, it's very important that I randomly assign which one they do first, because the order may have something to do with it, and I want to account for that by using random assignment. Okay. Lots of medical studies use matched pairs. And we are going to look at one simulation of a medical study in class on the block day. Okay. So when is it beneficial to use the blocked paired design? When there is something you cannot control for. So if there is a variable that you cannot control for, you can block for it. Okay, so You want to control for the variables you can, block for then any variables that you can't control for, and then use random assignment to help cancel out everything else. So control for the variables you can, block for then the variables that you can't control for, and use random assignment for everything else. Okay, I want to say one more thing. We've been through lots of experiment types and lots of sampling types. Something else that is very important is to keep them straight. Sampling has some terms and experiment have terms, and they sound like they would be similar, however they are still different. So in sampling, the most common one is called a simple random sample. And in an experiment, the most common one is called a completely randomized experiment. These are not as confused as much as the others. For example, sampling, I have stratified, and I have cluster. Those are my two other types of sampling methods. In experiment, sometimes people get these confused with blocking and matched pairs. They may say they stratified the experiment instead of blocked the experiment. Okay, blocking and matched pairs have to do with random assignment and experiments. Stratified and cluster have to do with sampling and go with observational studies. Keep your vocabulary straight. Do not mix up the language of experiments and observational studies because you will lose credit on both my test and the AP exam.